Figure shows a long wire bent at the middle to form a right angle. Show that the magnitude of the magnetic field at PQR and S are equal, and we have to calculate its magnitude. Now first of all, let's say this is my straight current carrying conductor of length, let's say L. Alright, and I have to calculate magnetic field at a point A. So what I do is I drop a perpendicular from here, and I joint the two extremities to the point A. Let's say this angle is phi 1, this angle is phi 2. So the magnetic field at point A is given by the formula mu naught I by 4 pi p. This p is the perpendicular distance of point A from the current carrying conductor into sine phi 1 plus sine phi 2. Now this is the formula that I use. Okay. Now let's say calculating the magnetic field at a point P. Alright. For point P, I have mu naught I by 4 pi p sine phi 1 by sine phi 2. Net magnetic field at point P will be due to this current carrying conductor and this current carrying conductor. Let's say this is my A, this is my B. So magnetic field at P due to A will be 0. Due to A will be 0, because in that case the point P is lying on the current carrying conductor. So clearly sine phi 1 plus sine phi 2, I mean phi 1 plus phi 2, both will be 0, and so their signs will be 0, and so BP due to A will be 0, and we will calculate BP due to B, that is magnetic field at point B due to B, and it can be easily calculated by formula mu naught I by 4 pi p. Now this distance is given to me as d sine phi 1. One angle, that is phi 1, is 0 over here, so it will be 0. Another angle is 90 degree. 90 degree in the sense that it will go towards infinity like this. Alright, so it will be 1. So I have mu naught I by 4 pi d. Now similar is the case if I calculate the magnetic field at point S. Alright, I do have mu naught I by 4 pi p, again 0 plus 1, mu naught I by 4 pi d. Fine. Now calculating the magnetic field at point R and Q. Alright, both will be same. I'll calculate only for one, let's say for point Q. Okay, now for point Q, the magnetic field will be given by, let's say, first calculate due to the A part. So I do have mu naught I by 4 pi d sine 0 plus 1, that is mu naught I by 4 pi d again. And if I calculate the magnetic field at point Q due to B, then it will be 0 again, because again if I extend this via B, then point Q will be lying on it, so magnetic field due to B on Q will be 0 again, and so is for point R. So in all, I can say that magnetic field at P is equals to magnetic field at Q is equals to magnetic field at R, and that is equals to magnetic field at point S, and whose magnitude is equal to mu naught I by 4 pi d.